Okay, so look at this. So you got 3.2 day 1. We're gonna have 4 lessons on 3.2, and then we've got a homework and quiz due Tuesday the 13th, and then a test that Friday the 16th. The progress check, the Unit 1 progress check, like Part A and B, is due Friday. So you could go ahead and start working on those. They're from, Unit 1 is the last grading period that we did. So some of this stuff is pretty basic, like looking at some graphs and stuff. Like we didn't even talk a whole bunch about some of it because it's not too crazy. But you look back at the Unit 1 progress check, take care of that on your own time. It's kind of like a take-home test, so you can use notes, whatever you need to on those. So yeah, get those in. I'm not going to be here, I guess it doesn't matter. I'm not going to be here on Monday, but I don't see you on Monday, so that works out. Also, why I specifically chose some Monday golf tournaments so that I wouldn't miss lessons with y'all. Don't y'all feel so loved about that? Because I just can't miss lessons with y'all. I'm going to miss lessons later in the year because like Friday tournaments are like varsity tournaments, but we'll deal with that later. What's up?
Maybe just do the first 5.
You said to put it in the Stapplet, and it's like the one with the question mark. Do we just not put it in?
Which one was the question? Oh, yeah, don't put that one in.
Okay.
Yeah, so let's go. What we're going to do is we're going to do the whole first page, 1 through 6, in your group or on your own. You're going to answer 1 through 6, and you're basically using this data that they had on the rubber bands and the distance the Barbie traveled, and you're going through, you're using some stuff on Stapplet, and then it asks you each question. So you're going to go through 1 through 6 on your own, and then we're going to come back together and talk through some vocab words from it, okay? Alright, so ready, set, math.
Wait, where do we put in for the?
Yeah, on the question mark, just don't put anything in.
But it says the hour has been
I want to see that.
Yeah, so you put 5, so don't put 5. Yeah, so that's an important note. So, yeah, do not put 5 or question mark. Uh-oh. Thing's not working. Oh, there we go. Don't put that. So, not in Stapplet. You're gonna do that on, you're gonna predict it on number 2 and 3 and talk about that. But yeah, so don't put that in. On Stapplet, you choose the 2 quantitative variables.
I'm doing it on the phone and it's not in
Oh, I think you put the collaborative one on accident. Not the collaborative, but just that. Yeah. Because I could have done a collaborative where I see all of y'all's different ones, but we're all doing the same thing, so it doesn't matter. That would be like if you gathered data, that they gathered data. Alright.
Oh, we do have to write.
So follow the prompts 1 through 6, and then we will go backward.
I don't like how it puts the whole number before the group or the 5.
So it should be about, like, if you follow your line. 65-ish.
What do you mean by?
Like for number 2.
Oh. Yeah, that's, yeah.
That's good. That's like some.
Right here.
Oh.
But the more you can show that you know what you were doing on the AP test, on like a free response, if you screw up, like plugging in a number or rounding, then you get more credit than like a 0. You know, if you just plug in what you got from the calculator and it's wrong, they don't know if you just were completely guessing or you actually knew what you were doing and you made a silly mistake. So.
So it's 7.46x. Oh, you already did.
I like show my work for number 2 if it's just getting it
Just
together?
write the equation out that like you use to predict it.
Okay.
So like, yeah.
Yeah.
Huh?
Yeah. I'll probably do whatever I like
We can just, we can add, for the number 3, can we just like. Oh, okay, that makes sense too. I did that. It's a
This could be used
for number 4, you said it was
with trouble with 20. I'm just gonna, yeah.
Oh, it was 2. I was thinking of yours.
Alright, let's see. Seems like we're all about there. So let's look at it. So nothing too crazy here. Go to Saplet, make a scatter plot.
Whoa.
I think the scatter plot was looking pretty linear. Okay, click least squares regression line, and you should have gotten something like y equals, what did I do, 25.333 plus 7.464x. So you wouldn't get it wrong if you put like 7.464x plus 25.33. The reason it's written like this in statistics is because we don't do this in this intro to statistics, but like in real world, you're probably gonna have more variables. So like then you can add on number your x2 plus number, the next number x3 dot 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 dot
Oh,
dot.
like.
So like you keep adding more variables. For our sake, we're always only gonna do one
And
variable.
that's why like the variable is.
Yeah, that's why the variable's not up there. But it really, you wouldn't get it wrong if you put 7, the thing with the x first, like you've seen it your whole life before this. So yeah, that's the equation. Some important things to note here between this one are, if you put y, we want to make sure to put this little caret over the top of it. So it'd be called like y hat. So what that represents, so what this little hat represents is that is our predicted y. So where they get, they're kind of a stickler for you not saying that this is your actual y value, but this is something to predict our y value. Like this is not going to give us the exact distance of rubber bands, or the distance traveled, but this will give us like a predicted distance if I plugged in x. So that's important. Another way that I wrote down is that sometimes they like you to just put like you actually write out your y value. So like you put distance equals 25.333 plus 7.464 rubber bands. I don't think you would get counted off, but sometimes they write it like that, and sometimes they like you kind of they like it. I don't know. They like seeing the variables written out, so that they're truly knowing like, hey, do you know what that means? Okay, use the regression line to predict the distance traveled for 5 rubber bands. So you plug in 25.333 plus 7.464 times 5, and yes, please write it out and write, distance predicted or do your y hat, because if in the instance that you plug it into your calculator a decimal wrong or something like that, at least you are showing that like you know what you're doing for little things. So make sure to do that. And I got what, 62.653 centimeters? Is that what y'all got? Sound about right? 62. So you'd have like distance. So you could either write it as like distance with the hat. So like, or you could say, that is like your predicted, again, kind of, they are stingy on like, this is our predicted distance equals, what did I say, it was 62.653 centimeters. Got a question, Rachel?
Yeah, so should we round or keep it as it is?
Like round all the way to 63. I think since they were rounding here, I think if you rounded, that's fine. But maybe don't round too much if they're giving you that. Okay, so student of the month. So yeah, you on this one, since they already, I think these other values were rounded, I think that's fine. But sometimes I would just go with like at least a couple decimal places to be safe. Yeah. So the predicted, because then these are like our actual values that we got, but like our predicted line was maybe cutting decimals between there. So the predicted line, it is nice to have it in decimals. Okay, where are we at? Number 3. What did we do? So number 3, one of the group members found out later that 5 was 64 centimeters. Was the prediction for number 2 too high or too low, and how far off were we? So I think we were too low, right? And we were, I think it was 1.347 centimeters, too low. And so you did, because you did how far were we? We're 64 minus that 62.653 equals the 1.347 centimeters. So our prediction our prediction was low compared to that. So what this number is, the vocab word for what we just got, our prediction and our actual were different. There's a difference, there's a distance between our predicted and our actual. So what this value is called is a residual. So this is an important term for the unit, something called a residual. And I want to draw a picture along with this. So I have my residual. So your scatter plot, you had a scatter plot, and it had some values that were, well, that probably wasn't a very good value there, that were pretty linear. They were probably, I think they were better than that. And when you do it on Staplet, I think when you click that equation, it put the line on there that equation was going at on Staplet. It gave you a nice picture like that. So what is this residual? Maybe I need to zoom in on my little picture here. So here's my predicted line. A residual would be like at the value for 5 rubber bands, I had a number that was actually at 64 centimeters, but my predicted line for that one at 5, we said was 62.653. So what is a residual in like a picture of it, is the residual is that little distance right there. So what is a residual? It's that distance that is different, whatever that distance is. So if you have a residual that's 0, that meant you were perfectly lined up with the predicted line. But for the most part, like if you look at your scatter plot, the line doesn't go, it goes really close to all of them, if I remember right, but it's not perfect. So there's a bunch of little residuals, like, I can't remember, but let's just say at 4, let's say I had one that was here at 4, and maybe the predicted value was here. So I had a residual that was lower than, like, I don't remember, but let's just say, so 4 was at 55, so there's probably a high residual. But whatever value is different from the predicted, that is your residual. It can be positive or it can be negative value. So like on this one, our residual was positive 1.347 because I was positive above it. Let's say this one was, I don't know, 0.5. So this would be like a negative 0.5 centimeter residual. If it's below, if your actual value is below the line, it's a negative residual. If your actual value is above the predicted line, then it's a positive residual. And the formula for a residual is you do your actual value minus the predicted. So this is something that seems to be missed a lot every year, is this whole residual thing. Like, a residual, I think the best way to get it is by thinking about what it looks like on a picture and putting your values. And then you see, is it positive or negative? But to get the residual, here's another trick to remember it. It's actual minus predicted. And think about the class you're in. You're in an AP statistics class. You do actual minus predicted. So that's how you calculate the residual or something. Actual minus predicted, AP statistics. Okay. All right, so that's residual. There's a lot, every single point has a residual. It's either a 0 or it's like a big positive or negative number. Okay, number 4, predict the distance that our Tigers, or Barbie, would travel if the group used 20 rubber bands. And would you trust this prediction more or less than the prediction you made in 2? So, let's see. I'll do what I asked y'all to do. I will write out my answer with the thing. So, equals 20. So you got 174.613 centimeters equals your y hat. So that's my prediction for 20 rubber bands. And do we trust it more or less than our 5? Why'd you say less?
Because like as you're increasing, the amount of the residual can increase as well, so like there's going to be like a greater difference.
Okay. Yeah, so like on our, where are we at here? So we got on our graph, the number of rubber bands only went to 7. And like at least 5 was like within our distribution here. But like on this one, I guess I'll just make a new page. So like the 5, that's a horrible picture here, but our 5 was at least like in the middle of our distribution. But the 20 is like, I'm guessing way out here. That's like me saying like right now, Ellie, my daughter, is like in the 65th percentile for height. Just because she's right there right now doesn't mean she's gonna be above average height when she's 18 years old. Like, she could tail off. I had plenty of friends in high school, or in junior high, where they just like shot up, you know, and then like they stopped growing and everyone else kept growing. So, it's more dangerous. It's easier to predict where we already are. It gets a little more dangerous out here. So, what this is called is extrapolation. Yep, I know how to spell. Extrapolation. Wow, except I did L-O. Wow, let me just respell that word. Extrapolation. There we go. Extrapolation. So extrapolation is when when you're trying to predict outside of known data. So you're extrapolating. So like that's what we're doing with the coronavirus all day long. Like we're extrapolating like, oh, this is gonna be this many number of deaths, or like we're not gonna get the vaccine until this. Like we don't know, we're just on some sort of trajectory right now, but we don't know if the trajectory will go like this, or like this, or it could keep going. We have no idea, but we maybe have a really good odds. Like right now, it looks like it's going to keep going straight, but we're not completely sure. We can have a good guess, but it's not a great guess. So that's extrapolation. So it can be dangerous, but sometimes you just have to do it. Like, it's just part of it. Like, it's just known if it's out there, it's a guess. It might be a good guess, but we're not 100% sure. Okay. Again, I think that's pretty kind of understandable. A lot of statistics here at the beginning of the year seems it's just real life stuff that's like, oh yeah, we've already seen this. We just maybe haven't put vocab words to it. So a residual, extrapolation. Okay, what is the y-intercept of the equation of the regression line, and what does it mean? So on these last two, the important part is the interpretation of these. So are you interpreting what y-intercept is correctly? Are you interpreting the slope of a line correctly? That's the main thing. Y'all all passed Algebra 1, so I think y'all know what a y-intercept is and slope and where to find it on the x, but like, what does it mean is kind of the big thing. So the y-intercept on our equation is our 25.333. It's our value. And so what does that y-intercept mean? What did y'all say? Someone want to say their answer?
That's how big the Barbie was.
Okay, yeah, like that's how, yeah, that they're at 0 rubber bands, it was just hanging 25.33 centimeters. Yeah, so basically that's how big the Barbie was, that's right. So yeah, and just though, it's when x equals 0. So when we had 0 rubber bands, 0 x's, the y value, and here's a main thing, so I'm going to change the color here. The predicted, and I'm doing it in caps for a reason, the predicted distance is 25.33 centimeters. Right, because we actually did this, so if I come back here, the actual distance was 25. So our slope of our line of best fit was at 25.33, but like we actually did the distance and the actual distance is 25. So it is important to mention that that value is the predicted one. It's not the actual value. So there's a difference. So when we had 0 rubber bands, the predicted distance was 25.33. So when x equals 0, that's what the y-intercept is. So the slope of the regression line, so the slope, I'm running out of room, so maybe I'm going to go to my other page here. The slope was that 7 number, 7,464. And what does that value mean? 7.464 centimeters. Anyone have a good answer on that one?
How much increases each time the distance?
These are clearances.
I have no idea, we're just supposed to.
Gloves. Hello. Now that the football season's done. Whoa. Yeah, you can come play. All right. Gloves. What am I gonna do with gloves? Sorry, online people. I just got delivered with gloves.
I got one glove in her class the other day for an
If y'all need
experiment.
some whatever gloves,
I did an experiment.
vinyl, blue vinyl gloves.
I used one glove.
All right. So what's that slope mean? Slope of the line in context to this problem with rubber bands and distance. What does it mean?
Each time the distance increases, it increases by that number.
Okay, yeah, and each time the distance, each time the
Rubber band.
yeah, each time the rubber band increases, and we're gonna go by one value. So it's by 1. So that's kind of an important thing. So if I was to interpret, it would be for every 1. So this is like same for every slope that you'd ever have. For every 1x. So in this case, for every 1 rubber band added. So for every 1 rubber band added, the distance traveled, the predicted distance traveled, there we go, I'm catching myself. So and then I'll change the thing again, the predicted distance goes, and then give a direction. It goes up because it's a positive slope. It's not negative.
You can't say increases, you say goes up.
You could say increase. You could say the predicted distance increases. Increases goes up. Something that's saying it's positive. Don't just say the predicted distance is 7 point whatever. So the predicted distance goes up 7.464 centimeters. So some keys here on the interpretation. For every 1x, the predicted distance, and then have something about increase or decrease. And then you put your y. So that would be the same for just about any slope you could have. For every 1 kilogram of weight in your car added, the predicted miles per gallon goes down by whatever the slope of that quiz question was.
I didn't realize that you told me the
I
answer.
know, I
to the
told all of y'all the
previous
answer, I
question.
know. I did it on the notes the other day too, because I kept forgetting where I got that example from. It's because I was doing the quiz key and stuff. Okay, so you got, the main thing is just your interpretations, and they are sticklers on these interpretations, so having the correct ones. So for every 1 blank predicted goes up. And same for the y-intercept. So there's sticklers on it. So when you have 0 x's, the predicted distance is blank, not the actual, the predicted distance. Okay, sweet. So main ideas here. So you've got, I guess, talk about this. You got, oh, I did it wrong. I spelled it wrong again. Extrapolation. There we go. Extrapolation. So extrapolation is key. So it's basically, the gist of it is be careful predicting outside given data. So like, sometimes we can't help it. In the real world right now, we do not know what the future holds for things. But like, so you have to extrapolate. You want to do it wisely. You can do it wisely with things, but like, if you're just getting a couple data points and predicting it out forever, like, my daughter is going to be like in the 80th percentile of height in the future. Like, I have no idea. Just because she's 60 percentile right now doesn't mean anything later. Okay, so be careful predicting outside of given data. All right, the other thing, residual. So I personally like the picture example on this. So you have some data, whatever, and you have a line of best fit, your prediction line. That's what a prediction line is, that slope that you got. It has some sort of line that cuts best through there. We've got our line of best fit. And there is a ton of residuals made. This dot had a residual. This one's a residual. What's the distance between the actual x and the predicted x? So a residual, if I was to write it, so you've got your actual x value minus the predicted. Or no, I guess it's the y. It's not actually the x, sorry. The actual y value minus the predicted y value. I guess technically, they could ask you for the x value. They could give you the y. But it's most of the time going to be giving you the x, and you have to predict the y. So what's the difference between those two? So you've got like a negative, you've got a positive, you've got a negative residual, you've got a positive one, negative, a zero residual means that it is dead on the prediction line. That's all it means. So zero residual equals prediction and actual are the same. Okay, so if I've got a negative 1.2 centimeter residual, that just meant that my prediction line was actually above the actual distance. And a good line of best fit, which we're going to talk about later, a good line of best fit should have a good mixture of both positive and negative. Okay, and then maybe I'm not going to write it all out, but go back. The main thing here is interpreting. They are sticklers on interpreting the y-intercept and the slope. So getting those interpretations down. Like your y-intercept means when x equals 0, the predicted y value is at blank. The slope is every time I add one x variable, the y goes up or down, it increases or decreases by blank, whatever the slope is. So getting those slopes right. And also using the word predicted a lot. That's another important thing. It's the predicted thing, it's the predicted number, it's the predicted y, whatever. Don't leave that off, because then they'll think you're talking about the actual number. So these are things that are on the AP rubrics throughout the year that we've messed up on. All right, sweet. Look at this time, we're doing great. Okay, let's do A, B, C, D, E. Yes. Okay, y'all do the check your understanding. So look at number 1. It gives you the data, and then go for the rest.
Ew. A 2-year-old rat using that formula will be choking. I said a 2-year-old rat using the formula will be choking. Like Subway sandwich.
we've got lab rats in the first 25 weeks after its birth. And we've got a fairly strong positive linear relationship, and so they made a nice little prediction equation, linear equation for that. Interpret what that 40 means. What's that 40 mean in terms of x? So x is weeks since birth, and y is the weight in grams. So what it would be interpret that slope. It would be for every 1 week, for every 1 week, the rat's weight, and then it's a positive 40, so you could say the rat's weight increases, or oops, I just made a mistake. The rat's predicted, there we go. The rat's predicted weight, that is super important. So the rat's predicted weight increases by 40 grams. Done. So if you didn't put predicted, that sadly would be off on a free response problem, because that's just, they're very...
Would they just take off, like, you said how they, like, rated it, I don't remember what it was, but it was like a bunch of letters, did they just take off one letter, or would it just completely
Yeah, so unfortunately you'd go from an E to a P, and as soon as you go do that, like, now the biggest you can get is a 3 on that, like a 4 is the best on that certain AP free response problem. Now you immediately drop down to a 3, just because you left off the word predicted. So, yeah. Okay, so the predicted weight. Sweet. Does the value of the y-intercept have meaning? So we didn't talk about this because the last one had 0, right? The Barbie, we got the 0. This one, does it have meaning? It would be yes, because at 0, x equaling 0, so x equals 0 means basically how, like, what were they like at birth? But like if it didn't make sense, like, I don't know, let's go for the car weight again. Like, what would be the weight of the miles per gallon of a car when the car weight is 0? Like, that doesn't make any sense. Why would your car weigh 0? So sometimes, like, you have to think about it. Like, does x equaling 0 actually make sense for this data? So this one it does. It's telling us how much they weighed at birth. So that would be like, you could say yes, the rats weighed, oops, I did it, I think I'm about to do it again. The rat's predicted weight at birth is 100 grams. So the same thing, even I want to make that mistake. Yes, the rat's weight, no, it's the rat's predicted weight at birth is 0. So birth is x equals 0. You could also have just said when x equals 0. All right, let's keep checking, keep moving. So the predicted, I think, is like 740. When you do like 100 plus 40 times 16, I think you get 740. So the predicted weight, you could even say something like this, like y hat equals 740. I guess I should do my thing, grams. Okay, calculate and interpret the residual of the rat weighing 700 grams at 16 weeks old. So for me, just to make sure, I'm just thinking through when I was doing things. So anytime it talks about residual, I make myself a picture when here is our predicted at 16. So like, here's us at 16, our predicted was 740, and then they're saying that they actually, if the rat actually weighed 700, what would be the residual? So that's kind of probably, we all think differently, but I guess I like to use I like to see things, and so this is me seeing the residual. So now I can see that it is 700 minus 740. I need to have a negative 40 grams. The most commonly missed part of residuals is that you would put positive 40 instead of negative. Or you'd put negative instead of positive. So I think the picture helps. What's that?
Can we say it's 40 grams under the predicted?
You could say that, yeah. If you were interpreting it, you could say, yeah, the actual weight. Yeah, because then that's me calculating, so I should write some sort of interpretation. So yeah, it should be like the actual weight was 40 grams less than predicted. You could say something like that. So yeah, anytime it says calculate and interpret, you need to write, some sort, what does it mean? What does that negative 40 mean? So that means that our prediction was, our actual was 40 less. Or you could say the predicted was 40 more than the actual. You can do it the opposite way. Alright, and should you use the line to predict the rat's weight at 2 years old, use the equation to make the prediction and discuss your confidence. So at 2 years old in weeks, I'm pretty sure 2 years equals 52 times 2 is 104 weeks. And up top, they said the lab stuff was for the first 25 weeks. So we're getting pretty far away. Like, basically, here's my scatter plot at 25, and I'm trying to like quadruple the amount and predict it way out here. Quadruple the amount. So, should you use it? I probably wouldn't. It would be unwise to use it. So say no, or you could say it's probably not wise to do it. And you could also, use the equation to predict. So it'd be like 100 plus 40 times 104 is 4,260 grams, which is almost, that's about 10-pound rat. By the time that they're 2 years old, they're about a 10-pound rat, which, I mean, I guess rats can get pretty big, but 10 pounds seems, I don't know what the biggest rat is, but that's pretty big. So I don't know if I would fully trust that. So I would say no, like, should you use it? No, you could say unwise to use it, no. Because 104 is very far from max of 25 weeks. Like if I was trying to predict 30 weeks or 40 or something like that, like that's not that bad. But 100 is pretty big. Things can happen in our scatter plot. So that's extrapolation. Alright, sweet. So that's what we got. The main things of the day, extrapolation, residuals, slope, y-intercept, using the word predicted everywhere, as you saw me doing it, and just making sure to use it wisely.